Hello everyone, and welcome back to another video. I know that it has been some time, and I hope that you all are doing well. In front of me, I have a mystery wheel, and on this mystery wheel, we have 6 categories. The categories are Math Counts Sprint, Math Counts Target, Math Counts Team, AMC 10 1 to 15, AMC 10 16 to 25, and Amy 1 to 5. Each of these categories it is a set of problems, and when I spin the mystery wheel, it'll land on one of these categories, and I'll have to do a problem from the category that it lands on. Ready? Let's do this. Alrighty, we have AMC 10 1 to 15. Alright, so I'm going to be doing an AMC 10 problem from the 2020 AMC 10A, and we got 1 to 15, so I'm going to pick at random. I'm just going to pick a random number in my head. We'll do 12. We'll do problem 12. Alright, here's problem 12. Ooh, a geometry problem. Alright, I'm going to take a screen snip so that you guys can see my work. Alright, there's the snip. Okay, here's the problem. Problem 12. Triangle AMC is isosceles with AM equals AC. Alright, that's important. Medians MV and CU. Alright, so their medians are perpendicular to each other. And MV is equal to CU equals 12. And we want to find the area of triangle AMC. So there are quite a few important things to note. I'm going to just highlight some of the important ones here. I've already underlined them, but just to add some extra emphasis. Alright. So, we're only given 2 side lengths, and that's the length of these medians. However, we know that when 2 medians intersect in a triangle, the point at which they intersect is the centroid of the triangle. So P is the centroid. And the centroid divides the medians in a ratio of 2 to 1. So, since MV equals CU equals 12, we know that MP to PV is going to be equal to 1. And the same goes for CP to PU, which is also going to be in the ratio 2 to 1. Since they're both 12, we know that MP and CP both have to be 8, and PV and PU both have to be 4. So let's write that in the diagram. 8, 8, 4, 4. Alright, not a bad start. Next, let's use this piece of information that the medians are perpendicular to each other. Alright, so we have right angle here, right angle here, right angle here, and right angle here. Alright, so we can use the Pythagorean Theorem now on some triangles here. We can use it on triangle MPC. We have 2 legs that are length 8. We have this leg which is length 8, and we have this leg which is length 8. And that means we can find the length of the hypotenuse, which is going to be MC. MC equals the square root of 8 squared plus 8 squared by the Pythagorean Theorem. And this is equal to the square root of 128, which is equal to 8 root 2. Alright, so we know that MC is equal to 8 root 2. Okay, I'm going to erase some of this so that we can work on some of the other aspects of this problem. So let me just erase this part here. Okay, I will leave the rest there. I'll leave the part about where we calculate MC at the bottom. We can also calculate VC and UM. And this is because we have the 2 legs and we can find the 3rd side, which is the hypotenuse. So we know that VC is going to equal UM, which is going to equal the square root of 4 squared plus 8 squared. And this, when you calculate it, it's going to be 4 root 5. Alright, so we know that this is 4 root 5, and we know that this is 4 root 5. Something interesting that we also know is that MV is a median, so that means that AV is equal to VC. So AV is also 4 root 5, and since CU is also a median, we know that AU is also equal to 4 root 5. And finally, since this is an isosceles triangle, if we drop an altitude down from A down to side MC, it divides MC perfectly in half. So MC is 8 root 2, but we're going to have 4 root 2 and 4 root 2 here. So now we can use the Pythagorean theorem to find the length of the altitude from A down to MC. And I'm going to call this AX. So we can use Pythagorean theorem to find AX. And the way we're going to use it is we can know that 4 root 2 squared plus AX squared is going to be equal to AM squared, and AM is 8 root 5, so it's going to be 8 root 5 squared. Alright, so 4 root 2 squared, that is 32. 32 plus AX squared is equal to 8 root 5 squared. Let's calculate that really quickly. That's going to be 64 times 5. That's going to be at 320. So 320 minus 32, let's do that here really quickly. It's going to be 2. That's going to be 12, which is going to turn into 11. And this is going to be 10. This is going to be 11 minus 3 is 8. 10 minus 2 is 8. 2. So we have 288. So you know that AX squared is going to be equal to 288. We can also find AX. And if we take the square root of 288, keep in mind that 288 is equal to 144 times 2. So this is going to be 12 root 2. Now we can find the area of triangle AMC. The area of triangle AMC, all right, we denote area by these square brackets, and let's just add a triangle sign there. And this is equal to 8 root 2, which is MC, which is the base. Now we multiply by the height, which is 12 root 2, and then we divide by 2. Note that root 2 times root 2 is equal to 2, so we can cancel this part out. Now we just have 8 times 12. This is equal to 96, and we get choice C. All right, that's pretty awesome. Let's check our answer. Okay, here's problem 12. We have choice C here. Let's see if it's right. And yes, choice C is correct. That's awesome. All right, let's do one more problem, shall we? All right, let's see what we get. Ooh, we get any 1 to 5. This is going to be an interesting one. Alrighty, here are the 2020 Amy 1 problems. And we can just pick one of these. I'll do problem 2. I'm a huge fan of logarithm problems, so let's do this one. I'm going to zoom in here so that I can get a good snip. And let's take a snip of this. Alright. Sorry that some of the other problems are in the way. But I think we can make it work. Alright, so let's read the problem. Problem 2. There is a unique positive real number x such that the three numbers log base 8 of 2x, log base 4 of x, and log base 2 of x in that order form a geometric progression with positive common ratio, and we want to find the number x. Alright, so in a geometric progression, we have something, I'll just give you a quick example. We have like 1, 4, 16. That's a geometric progression. Another geometric progression is 9, 6, 4. Alright, and both of these have positive common ratios, but these are just examples. Alright, in a geometric progression, when you have 3 consecutive terms, the middle term is always equal to the square root of the product of the left and right terms. So let's use that in this problem. We have log base 4 of x. This is going to be equal to the square root of log base 8 of 2x times log base 2 of x. All right, and now we can write that log base 8 of x is equal to 1/3 log base 2 of x for some number x. And this is going to be true, and I encourage you to try a few examples to verify this. For example, if you plugged in x equals 8, you would get 1 equals 1/3 times 3. See? There we go. Okay, so we can use this here. We can use this also for log base 4 of x. And for log base 4 of x, you're going to get that log base 4 of x is equal to 1/2 log base 2 of x. Okay, so let's remove this left part here, and let's square both sides. to get rid of this nasty square root. Alright, so we square this here. And when we square that, we get 1/4 times log base 2 of x squared. Like this. Oh, sorry, let's change that to 1/4. And we have a log base 2 of x on both sides. And we can actually cancel the log base 2 of x out. So when we do that, and remember, we're still going to have a log base 2 of x term because it was squared, so we just divided it by log base 2 of x. Now we have log base 8 of 2x equals 1/4 log base 2 of x. Okay, so let's take this log base 8 of 2x. Remember what I mentioned earlier, that this is going to be equal to 1/3 log base 2 of 2x. Okay, let's get rid of the fractions here and let's erase this middle part. Okay, let's get rid of the fractions. Alright, so this is going to be a 4 here, this is going to be a 3 here. And now we have the same base, so I'm actually going to bring this coefficient back inside the logarithm. And I'll show you how I'm going to do that here. I'm going to shift to the left, so we're going to have log base 2 of 2 to the x to the 4th power. We're going to take the coefficient and bring it as an exponent, and we're going to do the same with this part right here. This is going to be log base 2 of x cubed. Now we have a log base 2 of something and a log base 2 of something. If the logarithms are the same, we know that the part inside the logarithms also has to be the same. So we can see that here. 2x to the 4th is equal to x cubed. This is going to be equal to 16x to the 4th is equal to x cubed. And we can divide by x cubed on both sides to get 16x equals 1 or x equals 1/16. The problem asks for the number x to be written as m over n, where m and n are relatively prime positive integers, and we want m plus n. So we have 1 and 16. Those two are relatively prime positive integers, and 1 plus 16 is 17. So our answer is 17, or since it's Amy, 017. Now let's check our answer. All right, we can delete this snip as well. Let's see, so we had 017, and that is correct. That's awesome. All right, thank you so much everyone for watching. If you enjoyed this video, please leave a like and subscribe. And if you would like to see more videos like this, such as other ones involving the wheel here, please leave a comment down below. Thank you so much and have a nice day.